Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. So friends, today's video is part 3 of the thermodynamics, in which we will study about the internal energy. So let's have a look. Internal energy. What is that? So according to definition, the sum of all the type of energies contained by a system is called its internal energy. Now let's understand, if we have a container and some liquid is there inside. So that liquid is made up of small particles. We studied earlier that any matter is made up of particles. Each particle has its own energy. So together all the particles make the liquid, and that liquid has their own energy, and that together it is called internal energy. It may be rotational energy, it may be kinetic energy, it may be potential energy, it may be electrical energy, any type of energy, or the sum of all the energies together. So a system having some kind of energy itself, that is called internal energy. Now internal energy is denoted by capital U. It is a state function. We studied earlier the term state function in part 1 of thermodynamics. So it means internal energy always depend on the initial and the final state of the system. It never depends on the path of the system. Fine. Suppose we have to change the internal energy and we use two paths. Like we have to raise the volume of the water in a container, and one thing we can do, that we can do mechanical work, like put the churner and start churning it. So by that churning, the internal energy will increase. In the same way, doing some other work, like put the immersion rod in that container and start it. So again the internal energy will rise. So there is two different paths of giving the temperature to the system. But we will see that internal energy will not depend on path. It will be the same in both the case, same in the change we are telling. Okay, so that's why it is called the state function and it's not the path function. Next point, it is an extensive property. It means the internal energy always depend on the amount of matter used. If we take small amount of the sample, the internal energy will be less. If we take the large amount of the sample, the internal energy for that sample will be more. So it is called extensive property. Next point is the most important, that we are not able to tell the exact value of the internal energy. But the change in internal energy can be measured. Let me explain you. We have a bottle in which water is there. Okay. So if somebody asks what is the internal energy of this system, we are not able to describe. But if somebody asks what is the change in the internal energy of the system, if the heat is given or we shake the bottle, there will be a change in internal energy, as we studied earlier. Now how much the change, that we can determine. So we are able to determine the change in internal energy, that is denoted as delta U. So for the further studies, we will always study about the change in internal energy. Now come up to the next point, change in internal energy. As we understand that we are not able to measure the internal energy of the system, but we are able to measure the change in internal energy. Now how we can change the internal energy? There are three ways to change the internal energy. First one is to give the heat, that is heat passes into the system or heat is coming out of the system. If this process is going on, then definitely the internal energy will be changed. Like if we have a container of water and we give heat to that temperature, that means we are putting it on the gas stove and start the gas, then what will happen? The temperature of the system will start rising. It means the heat is given to the system. And in this way, internal energy will be changed definitely. Earlier it was something and later it will be something, because there will be a change in internal energy. In the same way, heat is coming out of the system. If we have a hot water container and we keep it aside, after few hours, we can say, or few minutes, the container become normal. The water inside the container become normal. It means the heat goes out from the container to the surrounding. Now here the heat is going out and the temperature is lower down in the container. So heat passes out of the system. Again, in this case, internal energy of the system is changed. Earlier, when the boiled water is there, the internal energy is different. When it is cooled down, the normal water, its internal energy is different. So what is the change that we can determine? Fine. Next point which is important is work done on the system or by the system. The second way to change internal energy is by work. If we work on the system, then internal energy will be changed. Like if we, as I told you earlier, we have a container and water is there and we have to change the internal energy. What we can do? We put the churner and start the motion of that churner. What will happen? The temperature will change inside. It means the internal energy is changed inside. So this is work done on the system, by which the internal energy is changed. So after that, the third point by which internal energy is changed is matter enters or leave the system. If matter enters in the system, its internal energy will be changed. If matter is coming out of the system, definitely its internal energy will be changed. So these are the three ways to change the internal energy: heat, work, or the matter. Now, sign conventions for the change in internal energy. Sign convention. This is important for the point of numerical. If first one, if energy is released by the system, internal energy is negative. How? If energy is released, it means inside, because internal energy we are talking means inside the system the energy, that is called internal energy. If energy is coming out, released, it means inside there is now less energy from earlier. It means we can say there is a loss of energy, and loss of energy always denoted as negative. Fine. So when there is energy released, we will use negative sign of the delta U. Next comes if energy is absorbed by the system. Now energy is absorbed by the system, it means there is a gain in energy. Gain in energy of the system, that is internal energy. So if the internal energy is gained, it means it should be positive. Okay, the sign will be positive for delta U if there is a absorption of the energy by the system. Now the third, and which is very important point, for isothermal process. Isothermal process we studied earlier, the process in which there is no temperature, we can say the process in which the pressure is constant. If the pressure is constant, means inside and outside pressure are same. Inside and outside means in the system and in the surrounding. Temperature are same. So temperature is constant. Then internal energy will be 0. That is delta U is equal to 0. Why? Because we knew that heat transfer from higher temperature to lower temperature. If there is no temperature difference, both the temperature are same, then there is no flow of heat from inside to outside, neither from outside to inside. There is no flow of heat. If there is no flow of heat, then there is no change in internal energy, and that's why delta U is 0 in isothermal process. So friends, I'm sure now internal energy is clear with the sign conventions, which is the most important part of the change in internal energy. So keep studying with me. Do like, share and subscribe the channel, and don't forget to press the bell icon. Till then, thank you.